Doctor, but I didn't get why Tata 2 is like that. Like first we took it from this line to the link وبعدين هونيك خدناها من اللينك للline. Doctor, you're muted.
Yeah, thank you. So what we said basically, Tata, right? Here, what I'm doing is I'm doing basically whatever that we did was the DH, right? We said Tata 1 is the angle between what? Very brief, right? So Tata 1 is the angle between x0. So this guy is my x1, right? And x2 is like this. So Tata 1 is the angle between x0 and x1, right? So this is my x0, okay? Tata 2 is the angle between x1 and x2, right? Okay, so Tata 2 is the angle between x1 and x2 about z1, right? In this case, it's a planar robot, so we know my z vectors will always be perpendicular to the length, right? So Tata 2 is angle between x1 and x2. Here, Tata 2 will actually again be an angle between x1 and x2. So this is my x1, and then this is my x2. So you're measuring basically the angle, right? About this vector, right? About z, which is like that. So basically you are, wrapping around it all the way from x1 down to x2.
Okay, I got it. Thank you.
Okay. So this is a planar robot, right? Okay, let's quickly actually put the DH frames on this robot. We should probably have done it before I did that, but that's fine. Okay, so this is, let's do this and then that. Okay, so this is my robot, and then this is my x0, and then this is my y0, and then my z0 is like that. Okay, can someone help me out? How can I put the DH frames on this robot and their origin? Right? Where do I have the motors, by the way, right? I have one motor here, مظبوط, and then I have another motor here. You guys agree?
Z0 ظابطة معك.
Okay.
Z1 بدها تكون كمان مثل Z0 بس فوق.
Exactly. So Z1 has to be here, right? So the Z1 is the axis of actuation, and then Z1 is what? Connected to link 1, ما هيك? So Z1 would actually, no matter how link 1 move, you can, think of it like, you can animate that in your head and think of Z1 basically is moving with the first link. Okay. All right. How about Z2?
Z2 ما بتفرق إنه.
Exactly. It doesn't matter what you put Z2, right? It does not matter, right? But we're going to put it like that for simplicity, okay? How about X0? So X0 is already provided. So, this guy, X0, Y0, Z0 is on the ground link, right? Like, let's say this guy is connected to Earth, right? Or, platform or whatever it is. How about X1?
Along the link 1.
Exactly. So X1 is here, right? Along link 1. So X1 is perpendicular to Z1. And also Z0, and also crosses Z0, right? How about X2? X2 is going to be like this. Okay. If I want to put the angles, right? Theta 1 will be the angle between X0 and X1. Here, I'm simply putting the absolute values of the angles in the DH table, right? Before we had theta plus 90, here I'm actually putting the actual value of the angle. So theta 1 is the angle between X0 and X1 about Z0, right? So this is a clockwise direction of Z0. Okay, how about angle theta 2 will be actually here, right? The angle between x1 and x2. Okay, now I need you guys to help me solve the inverse kinematics of this. Okay, let's actually try and then solve it. Okay, let's on a new paper. All right. So this guy is my XE, YE. So if I gave you these two, right, and I need you guys to be able to help me to find, this is my X0, Y0. Okay, we need to find theta 1 and theta 2 based on XE, YE, right? But you will tell me you need to know something about the robot. You need to know the actual geometry, right? So I'm going to tell you that the length of the first link is L1. And the length of the second link is actually L2, right? Now, how can I solve for theta 1 and theta 2?
دكتور مش فينا نعمل الدي اتش ونرجع نعملها انفرس او ما بتظبط؟
You can, but it will be a bit difficult to
I
do.
think
Any
yes,
part-
yes. I think the inverse with the unknowns, it will be difficult. Not fair.
It will be exactly. It will be, you're solving for theta 1 and theta 2 based on, a nonlinear, sine and cosine function, right? Well, we can kind of tell, right? If you do the DH frame, right? What do you actually get for XE? Can someone help me out? If you are doing, the output of your DH function, right? What is the output of the DH function? Ultimately, if you, the frames that we actually had, we're going to have, x2 in frame 0, we have y2 in frame 0, z2 in frame 0, which we don't really care about right now. We don't care about the orientation. We're only looking at that point. But what would be my x component of xe, basically? What am I actually going to get here? I'm going to actually get xe, مظبوط, ye, 0, and then 1, right? Okay, if I actually put the DH frame, I'm going to actually get this. But instead of actually getting xe, I'm going to get xe as a function of the angles, right? What is xe in terms of L1 theta 1 and L2 theta 2?
XE, it's L1 cosine theta plus L2 cosine theta 2. Theta 2, yes.
Okay, so xe is going to be equal to L1 cosine theta 1 plus L2. It's not cosine theta 2 because you actually also have to add this angle, right? So this angle here was theta
Yes,
1,
yes.
right? Here, when you are doing the DH frames, basically the angles are only relative, right? So if the angles are relative, why? Because if one joint is not moving, then the whole thing is basically behaving as one rigid body, right? It's not absolute, it's relative. So you actually have to incorporate theta 1. So it's going to be L2 cosine what? Theta 1 plus
Theta
theta
2.
2. If you try doing this in MATLAB, you will actually see that the value after you do DH, right? DH02, you will see that this value here is actually that in MATLAB. All right. How about YE?
L1 sine theta 1.
Plus L2 sine theta 1 plus theta 2. Okay. If I actually provided you XE and then YE, it's going to be almost impossible for you to solve theta 1 and theta 2 based on this, right? So this is, right? So here, if I gave you XE is equal to 1, right? And let's say YE is 0.5, can you actually solve theta 1 and theta 2? It's not very easy, right? Because this is a nonlinear problem, right? So you'd have to, you'd have to basically pick a solution and try to approach it, right? Iteratively, right? It would be an iterative.
Doctor, it can be solved in a system of two unknowns. إذا عملنا develop cosine theta 1 plus theta 2, but it will be a bit long يعني.
No, you can't actually solve it like that because it will actually still be a nonlinear problem. Okay, so
حنكون فيها sine و cosine كرمال هيك.
no, still you will not be able to solve it because you're going to have a product of cosine and then sine here. Okay, so what we're going to do is we're going to try and solve it geometrically, which is much easier. Okay, I'll begin by showing you how. It's not very intuitive, but this is what you actually do. So what we actually have is that we have this line right here, right? We actually know the length of this line, right? Let's actually call this LE. Okay. How do I know the length of this line?
From the cosine rule, we can get it.
Well, we have XEYE, right? We can actually have the length of this directly based on what we have, right? So we know
عندنا coordinates
Yes,
Pythagoras.
xe squared plus ye squared square root.
exactly. So LE is going to be square root of XE squared plus YE squared. All right. So we have that. So we have the length of this line. What we have to do is we have to set up a very basic equality here. And what I'm going to do is I'm going to say L1 plus L2 cosine theta 2. So this guy, okay, squared plus this guy squared has to be equal to LE squared. Okay, so I'm looking at this triangle right here.
Yes.
Okay, so if you look at this triangle, you're going to get what? LE squared is going to be equal to what? L1 plus
L2 cosine theta 2
L2 cosine theta 2
squared.
squared plus what?
L2 sine theta 2 squared.
L2 sine theta. Exactly. Okay. So with this relationship, we can actually solve what? We can solve theta 2 directly. All right. Okay. So here we have basically one equation that has theta 2. If you actually expand this, and we have LE squared is known. So LE squared is going to be equal to L1 squared plus L2 squared
Cosine squared.
cosine theta 2 squared
Plus
plus
L1 L2 L1 L2 cosine theta.
plus L2 sine theta 2 square. Now you see basically L2 sine theta 2 square and L2 cosine theta 2 square actually
1.
cancel out. So I'm going to delete this guy and then I'm going to remove this guy, right? It will be L2. You open up the parentheses, this guy square plus this guy square. So we're good. We can solve theta 2, right? We can solve cosine theta 2. What is cosine theta 2 in that case? So cosine theta 2 is equal to LE squared
LE square minus L.
L1 squared minus L2 squared divided by 2L1 L2. Okay, so we have basically solved for cosine theta 2. So now I can solve cosine theta 2. Theta 2 is going to be the inverse, right, of this value. Okay, and if we have this, we actually have two solutions for cosine theta 2. Okay, one is plus and one is minus. Okay, now how can I find theta 1? How can I find theta 1 from here? So the way you can find theta 1 is you can actually find this angle right here.
أو دكتور
We
فينا
have
بس نلاقي
about 5 minutes, so I have to actually solve this, and we have to
yes,
get
إنه لقيت theta 1 I can use one of these equations to find theta 1 إنه ما theta 2 صار.
yes, you can, but again, it's part of here, right? So it will be a product again, right?
لا ما هي صار جوا صار ثيتا مثلا فينا نقول ان ثيتا 1 بلس ثيتا 2 هي صارت انجل وحده بنحل فور ات لانه ما صار ثيتا 1.
Right, but if you actually expand that, it will still be a nonlinear problem. But you can try it. We only have a few minutes, so I have to solve the second one and get going. So how do I find beta? I can actually find beta from by looking at the tangent, right? Exactly.
So sine of beta is equal to ye.
Yep. So tangent beta is going to be equal to what? Is equal to ye over xe, right? So beta is going to be inverse tangent of that. Okay. All right. So here the problem here is that if you are doing an inverse tangent, right? If both of those are positive, right, it will return a solution in the first quadrant, right? This is your right. If ye and xe are both positive, I know beta is going to be positive. Okay, we're good. If ye is if ye is positive and xe is negative, right, then I'm going to be if ye is positive, xe is negative, I'm going to be here. You guys agree? Somewhere here. If ye is positive, xe is negative. If xe is negative, I'm sorry, if xe is positive and y is negative, I'm going to be here. So this inverse tangent will actually always find it. But if both of them are negative, right, this function doesn't know basically that you are in the fourth quadrant. All right. If both of them are negative, basically negative over negative, basically you are back to positive, right? And it actually return beta to be in the first quadrant. What you actually have to do is you have to use a function that is a tan 2 basically. So beta, and this function is actually provided to you in MATLAB. And so a tan 2, it will actually take arguments xe, ye xe, right, or y and then x of a vector of an angle, right? If you have some angle basically. If this is the xe of it, and then this is the ye of it, and then this is your angle, right? This function, if both of them are negative, it will actually return the beta in the fourth quadrant. It will return the actual correct angle, right? It will not give you the positive angle. So you always have to actually, whenever that you actually have a tan, use a tan 2 because you will be able to capture the angle even if it's in the fourth quadrant. So you'll actually not have a problem. All right, now we have beta. How about that? How can I find the theta 1? So I need to actually find this angle, right? What is that angle? Let's actually call this alpha. How can I find alpha? I can actually find alpha from here, right? So I have this whole line and I have this guy here, right? So I know I'm gonna write it here. So tangent alpha is gonna be equal to what? This guy, right? What is this guy? L2 sine theta 2. We know that, right? So L2
yes. over LE.
no, it's not
over L1 plus L2 cosine.
L1 plus L2 cosine theta 2. Well, we have already solved theta 2, right? So what is alpha? Is a
2 tan.
a tan 2, right? A tan 2 basically, like I said, it will return the actual angle, right? So even if the robot is moving and this guy is like all of a sudden here, it will always capture it, right? There will not be a problem. And then this guy could be here or here, right? So a tan 2 of y over x, right? So L2 S2 L1 plus L2 C2 C2 basically meaning cosine theta 2. Okay, so this is how we do the inverse kinematics of a plane, 2 degree of freedom robot. Okay, guys, are we good on here?
Yes.
Very quickly, let me share my presentation just to show you the a tan 2 function again. What is the a tan 2 function is here. Okay, this is the a tan 2, right? So y and x. So if x is positive, obviously everything is good. But this function, MATLAB basically programs it basically like that because you have this continuity in the solution, right? So if your x is positive and then y is positive, it will simply add pi to it. It will basically do everything for you, all right? To make sure that your angle is always captured correctly. All right, guys. So I think at this point, we're good here. For the exam, make sure you are familiar with it. So I'm only posting obviously more on that, and make sure you are very familiar with the DH transformations, with regular homogeneous transformations, how you move, how you do coordinate transformations between various frames. This is extremely important. And just continue to watch the lectures, and I'll be posting another assignment actually very soon. So make sure you're also that has to do basically with inverse kinematics. Okay, guys.
Doctor, we have inverse kinematics in the exam, right?
Yes, we do have inverse kinematics.
Okay, doctor. Thank you.
All right. We do have inverse kinematics, but we're not going to have wrist inverse kinematics. We will not be doing inverse kinematics on the wrist. All right. So basically things like that, okay, like 2 degrees of freedom, like this one, or like the problem that I solved earlier. Basically I'm going to give you like 2 degrees of freedom. Maybe you should try to solve, all combinations of, rotational and translation. So the first one is translation, the second one is rotation, the first one is rotation, the second one is translation. Both are rotation, both are translation, right? And I could have, L-type shapes, etc. That is all what I'm asking you guys. You have to be very familiar with implementing the DH frames and then, executing the DH transformation correctly and solving it. Okay, guys, any more questions? So we said the exam has moved, right, by 1 day for you guys to be able to study more. So from Thursday to Friday, October 30th, which is going to be Halloween, basically, or 1 day before Halloween. All right, are we good? Any questions, guys? Just email.
Yes, everything is clear. Thank you, doctor.
And okay, all right, guys. Bye now.